If you are related with 3D printing somehow, you probably know there are two different types of really affordable 3D printers. FDM printers that use a spool of plastic filament and melt this through the hot end, and resin printers that use UV sensitive liquid and LCD screen to cure the layers. In this video we compare those two. I know this type of videos already exist and not less, but I'm going to do this from a little bit different angle. I'm going to print and build mechanical parts. Last few years I have printed a lot of projects, and I'm not printing models or chess sets. I'm building water pumps, gearboxes, some type of RC vehicles and so on. But I have used resin printed parts only a few times in my projects. That's why in this video I'm going to print and build bearings, worm gears and chains with both of those technologies. And big thanks to Creality for sponsoring this video and sending me 3 their new water washable resins. But okay, before we are going to build something, let's take a closer look how FDM and resin printers work. Starting with FDM printers. FDM printer uses a filament. There is a lot of different materials, but in this video I use the most popular one, PLA. First, filament goes to the extruder and it extrudes the filament to the hot end. For PLA, the hot end is around 200 degrees. The filament comes out from the hot nozzle that is constantly moving and layer by layer building a model from 0 to 100. There is also a lot of different nozzle sizes, but the standard is 0.4 mm. After a couple of hours or even days, your model is ready and you can do whatever you want with it. This is the really basics of how the FDM printer works. Resin printers, aka SLA printers, work way differently. First of all, the printer isn't using filament, it's using UV sensitive resin for the material. The resin is poured to the resin vat. Under this is 4K LCD screen. Not all printers have 4K screen, but this one, Nova 3D Whale U, has. The screen will light up under the resin vat and cure the right amount of the resin to build one layer for the model. It doesn't matter how big the model is, the whole layer is cured around 3 seconds. Depends on the printer. That's why resin printers usually are way faster than FDM printers. When the print is done, your model isn't ready. First you have to remove this from the build plate. Wearing gloves of course, because the resin is toxic. Then you have to wash your model with isopropyl alcohol. But you also can use water washable resin, as I will do in this video. In this case, of course, you wash your model with water. When the model are washed, it's time to cure them. For that you can use any type of UV light, including sunshine. But the best way is to own a wash and cure station. When the model is cured, then it's finally ready. Just keep in mind that washing and curing resin printed models is pretty messy process. And the resin is toxic, so always wear gloves and avoid the resin getting in your eyes or anywhere else. Because I have cats, I hold my room door closed and my workspace extremely clean. It can be harmful for them too. But what about the results? Well, there is no question about that. Resin printed parts looks way better, especially when the model have lot of small details. If this is about printing beautiful models, resin printers 100% beat FDM printers hard. And this is not new information. But the question is, are resin printed models also great for mechanical applications? Let's find out. Actually, before we are going to do this, let me introduce you the resin that I am going to use in the rest of the video. I will use Creality new water washable resin. Creality water washable resin has less odor than most of the standard resin products, and it requires only 1 to 3 seconds of exposure time on most monoscreen LCD printers. Creality water washable resin has good durability. Models printed by some water washable resins are easy to crack after absorbing moisture in the air, but using Creality water washable resin are less likely to crack and last longer. At the same time, it has good toughness to avoid breaking the prints. No alcohol or acetone required for post-processing. Using water from the tap is good enough to remove the excess resin on the models. Creality water washable resins are perfect for those who don't like smell of the alcohol. Sounds amazing, so let's try this out. Bearings that I printed with resin printer, I use Nova 3D Whale U and Creality water washable white resin, and for rollers I use Creality Halot 1 and black resin. I also printed one bearing with an FDM printer, and for that I use PLA and Creality Cerman T1. I start the assembly with the PLA one. These bearings goes together really easily. First I had to place one inner ring inside the outer ring, and then I just added those rollers between those. The only thing to keep in mind, every roller has to lay on the opposite direction than the roller next to it. And I have to say, this bearing isn't my design. I find this bearing on the Christoph Laimer channel. I have printed those bearings before and I know this is absolutely perfect design. If you are interested, I leave his video link down below. So here they are. Those M3 bolts are a bit longer than they should, but I just didn't have shorter ones. Right now they are not spinning really smoothly, but I know from the past that after a 10-minute test run they should wear in and spin like a fidget spinner. I also 3D printed an adapter for my drill, and let's run the test, shall we? I start with a resin printed bearing. So the test will look like this. I'm going to run both of those bearings for 10 minutes, or till they fail. If they fail, the winner is who lasts longer. If they don't, then we investigate the wear and how well they spin after the both tests are finished. And be noted, I'm running them completely dry, zero lubrication. Otherwise both of them will spin to the end of the test and nothing happens. End result will be then both are great. But I don't want this, I want them fail, I want them suffocate. So what's happened with the resin printed bearing? Every second it was harder and harder to hold this outer ring, and at the end the resistance was so great that the adapter failed. Plus after 1 minute I felt that the bearing was pretty warm, and after 2 minutes it was freaking hot. At this point I planned to cut this test anyway, because the bearing was pretty much failed. After it cooled down a bit I was going to find out what happened. I disassembled the bearing, and what did I saw? The rollers was sticking to the outer ring. It's difficult to see on camera, but the inner and outer rings, they don't have any significant wear. They are still pretty fine. But the rollers, well, they have worn. Some of them not so much, but some of them pretty hard. I didn't add the lubrication before, but now I do, to see will this bearing will be useful. I am using silicone oil, that should be absolutely perfect for this application. Well, it definitely spins better than before. I mean before the test. Not surprised that the lubrication helps. But it's not enough to gull this bearing. Well, it is bearing, but just not useful bearing. Okay, let's continue with the FDM printed one. So I ran the exactly same test on the PLA bearing too. This time it lasted a bit longer. FDM printed bearing didn't fail and passed the 10-minute test. Actually it not only passed the test, it also spins better than before. True, it's not perfect, but I'm going to add lubrication for this one too, then maybe it is. But before I wanna see the wear inside the bearing, and I didn't find any. Well, I didn't completely disassemble the rollers, but as much I saw, everything was excellent. So I lubricated the bearing, and will it now spin better? Well, of course, the question is how much better. And again, here is the resin printed bearing. It's not great, not even good, it's unusable. And here is the FDM bearing. After I add the lubrication, it's day and night. I think it's still not perfect, but really close. So you are the judge. But when I need 3D printed bearing, I think maybe 100% I'm absolutely sure I will choose FDM instead of resin printer. Warm gears and warm wheels. Those black ones are printed with Creality Halot 1 with black water washable resin. Yellow ones are printed with PLA, and for printer I use Creality Sermon T1. Printing worm gears isn't so easy as it seems. That's why I printed those in multiple directions. The problem is those worm gear threads. For 3D printers, those threads are overhangs. Printing worm gear at 45° angle and using supports with resin printer is absolutely pointless, because the end result is rubbish. And the resin printer can print this type of model upright without any problems. Printing worm wheel, there weren't any setbacks. FDM printed worm gears, completely opposite story. The worm that I printed upright is unusable because of those threads, aka overhangs. Threads are too fat and they won't engage with the worm wheel. But I printed two more. One sideways and one at a 45° angle. Well, those ones are better, but for sure not perfect. Well, actually, those are not really usable also. To get a bit better result out of the FDM printer, I lowered the layer height, and yeah, this helps. Still not perfect, but at least usable. Now my test setup is ready. To drive the 775 DC motor, I'm using this speed controller and I will use maximum power. The juice is coming from 3 cell 6 amp hour LiPo battery. So let's get started with PLA. Almost 8 seconds and the PLA worm gear threads are gone. And for sure it's melting damage. It's pretty clear you cannot run PLA worm gears dry. Actually any worm gear you cannot run dry. I mean even metal. Just a little bit of grease makes day and night difference. I know this because I have a whole video about 3D printed worm gears. In this video I printed worm gears with PLA, ABS and PTG. Then I did basically the same test, but in the end I did again same thing, but I added a grease. And yeah, I really recommend to watch this video, because the result was pretty interesting. But okay, let's continue with this video. Next, resin printed worm gear torturing test. Go! Okay, again, at 8 seconds, my test setup got destroyed. I will continue with the test, but because the test already stopped, let's see how the worm gear is doing. Well, not well. Threads still are there, but heavily damaged. But worm wheel is still pretty fine. I fixed my test setup and I continue with the test. I misclicked the button and I didn't turn my phone timer on. That's why I added the digital timer on top of it. The worm gear managed to run more tens of seconds, but between 45 and 55 seconds, a lot of chunks of the worm gear started to fly off. I ran this more couple of minutes and then I stopped because absolutely nothing happened. So all the damage happened somewhere at 45 seconds. This worm gear is heavily damaged, but way different way than PLA. PLA threads melted, but resin threads broke off. But surprisingly the worm wheel is still fine. Especially compared to the PLA one. So if it's time to print worm gears, which one to choose, FDM or resin printer? Well, this test that I did showed that resin printed worm gear performed a bit better than PLA, but PLA isn't the best material to print worm gears anyway. I need to include the results from my video where I tested ABS, PLA and PTG. Here we can see that PTG, which is also printed with FDM printer, did really well even without any lubrication. So there is impossible to say that resin printed worm gear is way better than FDM printed worm gear. Or is it? If I need to print worm gear in the future, I would choose resin printer. Why? This video point isn't to compare only performance, and in this case printing worm gear with resin printer is way easier and the end result is way detailed and better. So I love to call this straw, because it's impossible to say which one to choose because both of them have their pros and cons. But if you are interested more about worm gears, go check out my video about those. I leave the link down below. And keep in mind, always lubricate your worm gears. This is how those chains will look like. Like you just saw, the yellow one is printed with Creality Cerament D1 and the grey one is printed with Resin printer. Building this chain is really easy. In theory, you need one inner link and 2 outer links. To connect them together, you need one M3 25mm bolt and just push the bolt through all the parts. To secure them nicely in place, you have to use one M3 lock nut. Don't waste your time with the regular nuts, they will not work. Those will come loose really quickly and the chain will fail. But make sure you don't tie everything together too well. In this case, the chain will not work. Those parts have to move freely, but at the same time, those links cannot be too loose. Now when the first little part of the chain is done, you have to repeat this process many times more, as long you want your chain. I finished my chains off camera and we can go straight to the testing. My test setup looked like this. The FDM chain, yellow, is printed with PLA and also the sprockets. The grey chain is printed with Resin printer and with Resin, and also the sprockets. Both of those chains will be moved by 775 DC motor and with the same speed controller and battery that I used before. But okay, let's start. I will run the test for 10 minutes, or till one of the chain will fail. If they don't, I again investigate the wear and hopefully we have some information to do the conclusion. If you are interested, I tried to measure the speed of how fast the big sprocket turns. I had difficulties to measure this, but it's around 3000 RPMs, which means the small sprocket turning 6000 RPMs. Little oopsie doopsie. Chains didn't fail, just the sprocket wasn't attached to the motor shaft strongly, and it came off. But it was fast fix and I continue with the test. I also made sure that the big sprocket turns around the same speed as before. Then this happened again. I fixed it, tried to, and then I was available to run this more couple of seconds. And the test is over now. 2 minutes less than I planned, I believe it's not a big deal. But okay, how the chains are doing? Well, the FDM printed one is exactly like it was before. It didn't wear at all. Resin chain has a little bit wear, but it's so less it's hard to complain about. More like really fine scratches. But how about sprockets? The PLA sprockets have some minimal wear. Resin sprockets have worn, but still it's really less. I'm pretty sure that just a little bit of lubrication would avoid this little wear completely. So what is the conclusion? They perform basically same, but in my eyes the Resin printed chain is winner. The reason for that is printing process. Printing 30 inner link with Resin printer took me 1 hour and 23 minutes. And if we add the washing and curing time, what is maximum half hour, then it took me for total 1 hour and 53 minutes. But with the FDM printer, those 30 inner links took me 11.5 hours. Printing 30 outer link with Resin printer took me 45 minutes, and with the FDM printer 4 hours. So this is the reason why I will choose Resin printer for chains. So which one is better, Resin or FDM printers? Well, it depends. For sure, in projects that need practical or mechanical parts, there is a place for Resin printers. But do this replace FDM printers? No, I don't think so. Perfect is to have both. Then you can print and build everything that you desire. This video is more than 20 minutes long and it's time to go. But before, I wanna thank everyone who has enjoyed my videos in the last few years, have pushed the subscribe button and gave me honest opinion of my videos. This is the reason why this channel has almost 90,000 subscribers. Thank you again, Happy New Year and see you guys in the next video. Bye.